Okay, so we will go ahead and get started. As far as I can tell, everybody's here. So if you didn't hear me say your name, it's because I think I knew your name. Today we'll, I guess, address the first issue on how it gets scheduled. It gets scheduled kind of weird because I think our lab space is too small to have a conversation in. And so I would prefer to actually have seats that have backs and be not inundated with the hood noise. So I've been lucky enough to get a room that we have access to and no one's taken it away from me. So that's why we meet in here. It's officially scheduled in here for 75 minutes just because that's how scheduling works. That's it. But if we don't need to talk about anything, we don't spend any time in here and we go straight into lab. Okay, so it's kind of a flex time zone. That said, in a couple of weeks, I'll point it out, we will spend all of our time in here because it's not a wet lab, it's a dry lab where we will be using model kits and going through and doing activities to kind of ensure understanding of stuff. Kind of, sort of. It is a long lab. We run till, I think it's officially 4:50, or do they make it 45 now? 45. I try to aim for 4:30 as kind of the deadline that I would like you to be out by. That goal is easily possible. A lot of it depends on your preparation. The more prepared you are for the lab, the more likely that you can even be done before 4. Some of the labs push that limit. Some of the labs are way faster than that. Just kind of depends on the different scenarios. Kind of, sort of? Okay. So you should plan to be here till the official time, but we try to push to be out a little earlier. Okay. After that, probably should have started with Doobie and Shay. Was it Shay? Okay. I'm Mike. Sorry, didn't introduce myself. I'm your instructor. So, pleasure to meet you guys. Prefer to go by Mike, and we'll now spend the rest of the next hour and a half kind of going through kind of the course design, syllabus stuff, how you're going to submit assignments, all that kind of jazz. I do apologize. It is boring as all get out because that's what syllabus day is. But it will hopefully get over relatively fast, okay, or not horrendously slow. Canvas has the entire semester built out kind of already. So we've got week 0 and 1. This covers all kind of the basic stuff that you would normally get within a standard first week class, going through safety, things like that. There's some important stuff at the bottom that we'll come back and talk about. And then we would look, moving into next week, our first lab. You get the background information, which is linked, embedded within Canvas, so you should open that up, read that ahead of time. There's usually a link to some kind of YouTube video. Due to COVID, we had a bunch of stuff recorded, so I figured it made sense just to keep access to that available. You don't have to watch those, but they're just links out to videos. Sometimes they're very useful to watch, other times they aren't all that great. For instance, this first one I don't think is all that big of a deal because the lab is solubility. Mix two things, did they mix? Did they not? Okay, and that's what that video is me mixing them and not. Maybe with me providing audio over the top. I honestly don't remember. You'll see the pre-lab assignment. So we follow what I would have argued is a fairly standard pre-lab, but we'll have a discussion about what that means and what you guys have done in the past. Then we have the in-lab, so all the notes that you would be taking in-lab get graded. There's a pre-lab quiz for most of our experiments. I think there's only one that's missing one. The intent of those quizzes, you would do the pre-lab, you would read the background information, you'd come in, we'd talk about the lab, then I'd give you the pre-lab quiz. Okay, so it's not some kind of deep involved thing, it's really trying to push, did you understand what you read before you started the experiment? That's the intent of those assignments. They're shifted to online now because I found it was a waste of time to do it in class. Okay, that meant we could get out of lab faster if we didn't do them in class. Okay, and then we'll get our post-lab or lab reports I call analysis. And then occasionally you'll see a couple other things in here. This lit review is a new one, or not a new one, but occasionally shows up, and we'll talk about why that's there. And then the technique summary reminder is also another kind of larger assignment that we'll talk about as well. But if we scroll through to week 3, same deal. Background, your YouTube videos, pre-lab, in-lab, quiz, analysis, technique summary. Okay? So it's all built into Canvas. Week 4 is that one where we're just going to sit in class. That's the models activity. So I've got an assignment kind of built where you will just work with model kits to answer questions about what you're seeing, to kind of force you to use model kits. TLC, and then we get another long just in-class kind of one on spectroscopy. Okay, which is usually the section that most students complain about because it's a lot of stuff, and it is. Okay, but then yeah, we just move through each of the modules, do the experiments, and kind of move on. Kind of, sort of. Okay. A little bit on due dates, solubility. Okay, that's the lab that we're starting next week. What is today? 18th plus 7 is 25. Right? I think I did that math right. Which means we will be doing the solubility experiment on the 25th. When do you think you should have the pre-lab done? Before the 25th. When is it due? It's due the 26th. Okay, so you get a little bit of wiggle room within that due date. You should still be doing it before lab. This pushes back to that kind of, I want to get out of lab as fast as possible, so show up prepared. Okay? If you show up prepared, you're good. I put the due date there because maybe you come into class and you've got some questions. Let's get those questions answered before we make the assignment actually graded. Okay? In lab, it's what you're doing in lab. Okay? Theoretically, it should be done the 25th. Due date is again 26th. This is kind of pushing consistency, just making the due dates on Friday. Okay? Pre-lab quiz, also the 26th. So you actually get a little bit more of a benefit than students now 5 years ago had, because you come in, we'll talk about the lab, you will have prepared the lab, you will have done the lab, and then you can go through and take the quiz. So you can schedule out your time on when you want to complete that quiz, but remember the intent was kind of in class. So you shouldn't have to go through to do the experiment. You shouldn't have to do an analysis of the lab report to be able to do the quiz. Make sense? Okay. Last piece is the analysis. It is also due on Friday, but not Friday of the same week. You get plus 1 week. Okay? Kind of, sort of? Okay. If we go through and look at some of the details on these, the pre-lab, we'll open up the pre-lab, the in-lab. Might as well open the analysis as well. You get a wall of text within this, okay? All of this is the descriptions behind what's going on with what you need to have within the pre-lab. It looks excessively daunting. We're going to look at it in more detail in a little bit. Don't stress about it necessarily here. There's a rubric that explains what goes on within it. If you establish mins, okay, minimum of this is what I want out of the assignment, that's your score. And then there's ways to kind of improve your score. Note, it's not a huge improvement. Okay? Most people by the end of the semester, I'm just doing this pluses column, max credit all the way through. Okay? But those are usually pushing the assignment just a little bit further than just checking boxes. Make sense? Canvas is set up so that you can submit. Oh, this one says submitting nothing. Sometimes they say submitting something, okay, and that's because when I put in a due date for it, January 26th, if I don't have an option to submit, Canvas will now yell at you that you don't have a grade for it, like something is past due. Like you weren't supposed to submit anything, stop yelling at students. So then I put in the submit option. Now Canvas yells at students because you didn't submit anything. You didn't have to submit anything. But by setting up the submit option for most of these assignments, you can click submit, facepalm the computer, okay, and click submit. I don't read it, okay, because your pre-lab and your in-labs are not actually getting submitted into Canvas. Canvas is just the placeholder for the grading system, and that is it. Kind of, sort of. In-lab formatted similarly, okay, gives the descriptions, the analysis, okay, pretty much just tells you that you should go somewhere else for the post-lab, but here's some kind of the details. This is, again, for me to really just put in points so that we can record where your grade is. So then how do you actually do these assignments? Okay, that's where we go back to our week 0 stuff, okay, and I'll talk through some of this. Office hours, I forgot to talk about in class. Oh, well. I will be updating those probably by the end of today, based off of the poll that we took in lecture, or that some people took in lecture. It looks like Monday afternoons, Tuesday, Wednesday, Thursday in the 10 to 11 range, maybe 9:30 to 11 range, and then Fridays are usually spotty to begin with. Okay, but you can expect roughly those office hours. Embedding work in assignments. If you haven't worked with Canvas and embedding things into it, like here's a picture of my work, you should read through that because the quizzes will have you do that. Okay? And since the quizzes are timed, it makes sense to know how to do that before you start the quiz. Make sense? Okay. We'll skip the technique summary for the moment. We get all this safety stuff. Okay. This is now probably your 3rd semester at least of chemistry, right? Chemistry labs. In theory, you've been made to watch a bunch of safety videos. Okay. I've watched them a whole bunch. I'm sick of watching them. I don't want to make you watch them as well. Okay. So we don't spend time in class to watch them. It's all pushed online, which means I expect you to click this link and watch the Flynn safety video. Okay. I expect you to look through this safety online document, see what all the safety policies that Flynn thinks are important. I expect you to take the safety quiz. The safety quiz is an actual quiz. There's something like 20 questions on it. Okay. And I expect you to sign off on the safety contract. Okay. Pretty much all of those things say, okay, or the big bullet points, you wear goggles in lab. Okay. Not safety glasses, goggles. Sorry, it sucks, but we need goggles. Closed-toed shoes, appropriate clothing, and you listen to what I say. That's kind of safety in a lab. Okay. I would argue the other one that isn't listed there that I forgot to mention to everybody else is that when you don't feel safe, you tell me so that we can have that conversation to ensure that you are safe within the lab. Make sense? Second semester, if you stick around second semester with me, that's when we'll talk about or do more kind of dangerous chemicals. Most of this semester is relatively benign. They aren't horrible. There's some that are a little up there, but it's not that bad. Okay. Safety review evaluation, which I mentioned in lecture, but for those of you, 2 of you not in lecture, ignore the safety review evaluation for the moment. I can't figure out what's wrong with it, and I'm trying to talk with the people who manage that to tell me why I'm doing something wrong, and I'm pretty sure their directions just suck. But yeah, ignore that and just deal with the rest of the safety stuff. Questions about anything so far? Yes?
Last semester, my microbiology teacher had coats and goggles. Do we need to go purchase those?
You do need to purchase goggles. I don't force lab coats. Lab coats can be beneficial. Generally speaking, I would say don't show up in nice clothes and wear clothes. And it's okay. But yeah, if you've got nice clothes that you want to protect, then a lab coat makes sense. But a lot of it just comes to cost, and we're trying to reduce costs in the safety bump that you get with a lab coat just isn't really there. Other questions? Okay. Before we move into these forced copies, these two things are going to be things that you need for the course, because that's pretty much the meat of the course right here in those two documents. How many people took chemistry from Chandler Gilbert? Oh, interesting. When?
152 I took last semester, and 151 before that.
Okay. Same.
For me, it was when I was in high school, so 2019.
Oh, so it's dual enrollment? Yeah. Okay. Interesting. Okay. Thinking back to all of your chemistry experiences, what did you have to do for a pre-lab? I don't accept silence, but nothing is acceptable.
In my 151 class, we had to do like a little pre-lab sheet, just like write down information so we know what we're doing for the pre-lab. And then for my other class, it was just doing a pre-lab quiz, and that was it.
I just had a pretty low voice.
Same. Just pre-lab quiz, and we'd have to print off the
Procedure?
Yeah.
Okay. A little concerned about that. So one of our competencies, and particularly for all of the general chemistry things, is that you're supposed to be aware of safety hazards and all sorts of other things like that. And that's kind of hard to do if we don't make you do it. So yeah. This looks less cool then. It's usually cooler for students that had to do all that work in the past, and I don't know why we are entirely removing that part of the curriculum. So yeah, when you click that link, what you should get is something like I just went through, and what we'll see for the name of the document is, would you like to make a copy of last one, last two? Yes, you do want to make a copy, so you'll make a copy. This will get copied into whatever Google account you're currently signed into. I would recommend your student account, but it does not have to be. And what you'll get is this somewhat beefy document. The table of contents loads very strangely, but it's something like 30 pages, 34 pages of stuff. Okay. Let's walk through some things that we see up here. Well, actually, let's not even do that. You might look at this and be like, I don't even know what to do with this. Any hints or clues about what you think you should do with this?
Just click.
Yeah, that's a good idea. Let's do that. So if we click there, it gets us some directions. Okay, the first thing I want you to do is to rename the file. So if we go up here to the top, it says copy of last one, last two. Copy of is because it's a copy, so you should delete that. You don't have to delete that, but you should delete that because the directions say to delete that. It then says last one and last two. What are those referencing? Last names. You will be doing your labs as small groups, 2 people. So last one, your last name and your partner's last name, or vice versa, it doesn't really matter. But that way it's tracked. Okay. The next thing that I would like you to go through and do is that you should save this document so you know where it is located. I'm told that I'm apparently a boomer and I use folders, and nobody uses folders. I would recommend you find a place to save it that you don't lose it. If you just want to search your Google Drive every time you want to open it, that's fine. Okay? But I personally would recommend saving it in a particular location. If we go through and look at what I've got, I can show you what I'll end up doing here in a second, is that I would save it under academic year 23-24. We're looking at the spring. This is 235, and then pre-labs. So what will happen is I will save all of your pre-labs into this folder, so that when I want to go through and grade, I just go to that folder and I can open it up and I can see it. Make sense? Okay. But that assumes it's been shared with me, which is where step 3 comes into play. Step 3, we've got our share option, so click share. You should be adding my email address and your partner's email address. Okay. Again, I don't care who created it initially. as long as both you and your partner have access to the document and I have access to the document. Okay? You do not have to notify, like if you add an email, right? You can say notify people. Ideally, you notify so that I know that it's there. If you don't notify, I'll just search for it later because Google's nice about that. But yeah, if it's notified, I can drop it into my folder system ahead of time and be a little bit more prepared. Make sense? Okay. What you have now saved to your drive is every single one of our experiments. Okay. Procedures, outlines for pre-labs, outlines for in-labs. It's all now in one happy place. So if you think through how you took notes in the past, you probably had a notebook. How did you get feedback on the notebook? Did you know you were doing a notebook wrong or right? Okay. How would you figure that out? Okay. With it as a Google Doc, I can provide feedback. I will comment, okay, sometimes snarkily, okay, into your notebook about what's good or bad or what things you need to fix. Okay. Those comments are based off of what you're supposed to be doing for the pre-lab and in-lab. This document editing section is because I was super proud of a table of contents, because that table of contents, I don't know if you noticed it, but it was kind of neat, right? So right? If I want to go to the solubility lab, I can click here and I go to the solubility lab. I don't have to scroll to find it. Like it's awesome. And then some smartass told me that Google already does that for you and you didn't need a table of contents. Which was mildly depressing. But that's what all this stuff was here for, is I was trying to toot my own horn and show how cool it was so you could learn how to do it if you wanted to do it. You don't need to stress about it, but it's still there. So our lab directions. Okay, our pre-lab is going to be composed of 3 different things. We have an introduction. Come on, work with me. Introduction, chemical lists and hazards, and a procedure summary. Okay? These 3 things are doing what the pre-lab quiz or your pre-lab assignments were doing in the past. Okay? Same general intent. And then to that kind of point, what is the intent of a pre-lab? Why do we have you do that? Why do we give you a quiz before you start a pre-lab or start an experiment? Okay? To ensure that you know how would we know what you were doing? How do you know to know what you were doing or not? How did you prepare for that quiz? I mean, theoretically, you could say I didn't, but ideally you did something. How did you prepare for any of your labs? What did you do? You read the lab. Okay, that's the point of a pre-lab. Try and provide a paper trail to prove that you read the lab. That's the biggest goal out of it. So all of these things, tons of text, but the intent behind it is, did you read the lab? Give me a paper trail to prove that you read it. That's the primary goal. What's another goal? Why do we want you to read the lab?
It's understand safety still and chemicals we use.
You're dealing with safety. You're dealing with chemicals. Those could be hazardous. We want you to be aware of the hazards of those chemicals so that you can treat them with respect or a lack of respect if you really don't think they were hazardous. Okay, you'll find that most of the time I treat most of our chemicals with a lack of respect. Usually students freak out when I put on gloves because they're like, oh my God, what the hell are we working with today? Okay. Just because most of the time it's not that big of a deal, and also when I'm working with the chemicals, one of the things that students forget to see is that as soon as I touch and deal with a chemical, I go wash my hands. So the frequency of hand washing goes through the roof. You could choose to do that, but that delays your time in lab. That's why gloves are important for you. Okay? Kind of makes sense? So safety is important. This is where our chemical lists and hazards comes in. Okay? Why else? This is kind of a personal goal for you, believe it or not. Did anybody breathe kind of a sigh of relief when I said we weren't going to be here till 4:30? Thank you. I appreciate the honesty. Yeah, you're like, whew. Because what was your number one goal when you walked through that door or sat down to listen to this discussion? When are you going to get out? Okay? All people have that feeling, even chemists. When I walk through the door and start talking about it, it's when are we going to get out? When are we going to be done? Okay? To a lesser extent, because I talk too much. Okay? But we all have that goal. If you show up prepared, you get out early. So the more time you invest in the pre-lab to understand what's going on, the more likely you get done and get out the door faster. Okay? If you don't invest that time, instead, you're going to be investing that time in the lab space, okay, with me, for better or worse. Okay? So, introduction. The point of the introduction, did you read the background information for the lab? Do you understand or have a rough passing understanding of the theory behind the experiment? Okay, so what I want you to do is read the background information. Once you've read the background information, go to the introduction, write a couple sentences. This is not the introduction to a lab report. This is prove that you read the background. That's it. Okay? So, identify personal goals. If I look at your introduction and you're like, I want to survive my very first organic lab. Okay. Reaction drawings, there's no reaction. So if that's your one sentence for your introduction, you have satisfied the minimums for the assignment. On the rubric, you'd get 2 out of 2.5 for that very silly statement, right? I mean, it's not that silly. You do want to survive, but it's pretty easy to do. Okay? If you want to advance more than that, you need some of these pluses, and this is where Canvas fails. Clearly identify instructor goals. Okay? So when you read the background information, could you understand why I want you to do this experiment? Why do you think I want you to look at solubility? Okay? Identify that. Okay? If you use pictures, pictures are worth 1,000 words. Put a picture in. Relevant picture. Okay? Putting a picture of your cat in there doesn't help. Okay? Or your dog. Don't switch animals on me. Okay? Then the last one shows up commonly because you all usually come up with something creative that I didn't think of. Have you come up with some crazy organization system or thing that I hadn't thought about and I think it's cool? I'll give you bonus points for that too. Make sense? How much time do you think it should take to write the introduction? 5 minutes if we're including the time it took you to read the background information. Like that's the time expectation. Does that make sense? Chemical lists and hazards. Okay. Most of the experiments, I have not given you a list of the chemicals. Okay, what I've given you is the procedure. You need to read the procedure, identify the chemicals, and pull them out into a list. Once you have that list of chemicals, you need to know what the hazards are for those chemicals. So you have to do a little bit of research to look up the safety data sheets and interpret that information and get that summarized in your pre-lab notebook. Make sense? There are a couple other things that will go with that become relevant for us. Physical constants, we'll look at some of those physical constants, and structures for our chemicals. Okay, for those people in lecture, structure is everything we do in OChem, which is why we want our structures in our pre-lab so that we know what they look like. We can now start to draw conclusions about reactivity and all sorts of other fun things if they're present. That means you have to be able to draw something, maybe, for your notebook. Make sense? Okay. Did you list all the chemicals? Did you provide all the properties and give me all the hazards? That's your minimums. You want bonuses? Did you use the GHS pictograms? This is a fun question. What the heck is a GHS pictogram? Anybody know? That's one of those competency things that we should have a conversation with chem faculty to ensure that's appropriately done. GHS is the Global Harmonized System. I've only recently learned that. But what it's referencing is our common hazards, our chemicals. The lists of words that describe it can be difficult to translate, particularly if you're not an English speaker or if you're in a different country. Okay? They're going to use different language. So using language to describe the hazards isn't globally harmonized. Okay? The pictograms are now pictures representing those hazards. So if you see a bottle exploding as a picture on the thing, you'd be like, oh, that's explosive. You see a little flame on it? Oh, that's probably because it lights on fire. So you'll be a little bit more careful about those hazards because you're aware of that. So there are pictograms that represent them. It's using words and pictures in your chemical list. That's the bonus. Correct identification of products. Products are not always stated within the procedures. Sometimes they're in the background information. They are chemicals you will be working with. They should make it into your list. Okay? And then again, wildcard organization structure. Procedure summary. We will start with our primary goal or questions about chemical lists and hazards. Does that make sense? Sound kind of daunting? No? Okay. Well, then maybe I won't make it easier. We'll make it easier in a little bit. Procedure summary. In Gen Chem, you're given cookbook. Follow these steps. Do this, then this, then this. And yay, everything's grand. What you should be getting to now is interpreting a procedure to know what to do. Okay? Part of that interpretation is understanding why you're doing the actions you're supposed to be doing. I can't tell you how many times in Gen Chem a procedure says measure out 0.5 grams of a substance, and a student will measure out or 5.2 milliliters of a substance and measure out 5.2 milliliters. And then when it says obtain 100 milliliters of water for a hot water bath, they measure out exactly 100 milliliters of water. Well, when we say 5.2 milliliters of a substance, it's probably because we're reacting it. It's important to know that exact amount. For a hot water bath, how much water do you need? Enough that it keeps things hot. Why did we say 100 milliliters and not 500? Because it takes forever to boil 500 milliliters. Okay, why didn't we say 10? It wouldn't last long enough as a bath. So they're ballpark estimates. Why is that a big deal? If you're spending 5 minutes to measure 100 milliliters for a water bath, that was a waste of time. Your number one goal was to do what? Leave. Why are you wasting time making measurements? So that requires kind of a critical reflection back on what that procedure is asking you to do. And when we look at an organic procedure, it's not broken down into, oh, this is important for this or that. Even the Gen Chem ones didn't do that. You're supposed to be adding that extra layer of thought behind it. Right? The first pass to do that is to address the different things that you're doing within an experiment. And organic chemistry really boils down to 4 different things. I make something, I separate that something away from all the stuff I started with, I purify it, which is slightly different than separate. Right? We just talk about separate, we could be like male versus female. And then purify would be how curly your hair is. Right? We can do very refined things depending on what you're trying to do with your individual experiment. Right? So a separation can be crude, a purification needs to be very, very precise. Why does that matter? Well, separation, I don't need to waste a lot of time on. Purification, I do. Okay? Because there's different goals intended behind them. Make sense? And then the last thing is identification. So what I want you to be able to do is read a procedure and be like, these 4 sentences are talking about synthesis. This sentence is talking about separation. This sentence is talking about purification. This one's talking about identification. By breaking it down, you've performed some level of analysis of the procedure. Okay? Hopefully ensuring that you know more about what you're doing before you start. Okay? Past organic classes that I've been in, what they insisted students do would be to hand write out the procedure, that you were not allowed to have the actual textbook procedure. You had to write your own procedure. What did everybody do? You just wrote the textbook procedure down. You didn't read it, you wrote it. And if you've ever never transcribed things, you can transcribe without reading. Right? So it was a really silly assignment. So the procedure text is always given to you. I don't expect you to create your own procedure. I expect you to be able to interpret the procedure that's there. Kinda, sorta? Next part. Gen Chem. You just did experiments. There were no techniques involved because the techniques themselves were really simple. Do you know how to put water into a burette? Do you know how to turn the knob to let the water out of the burette? Okay? So we didn't have to do special training to get you to do those things. OChem, we do. Everything that you learn in the first 3/4 of this semester is a technique. It is not synthesis, separation, purification, and identification. It's identification. It's separation. And it is only that topic, which means having you try to break down the procedure according to all of those goals is kind of meaningless because not all of those things are goals. So what do I want you to do? This is the reality for OChem 1. I want you to read the procedure. I know, bizarre. Scroll away from the procedure. Write what you remember. You don't remember much? You don't remember enough to write anything? Then you should probably reread the procedure. Okay? Read it until you have something that you can write about. Okay? It does not need to be extensive. What you're trying to do is provide the evidence that you read the procedure. That is it. That's all I want as a minimum. Does that make sense? Taking it to the next level, identify the parts of the procedure that are actually happening. So for most of our experiments, it's just going to be, we're just going to do separation today. We're just going to do purification. Okay? If you provide links to walkthroughs, again, later in the semester, but say you watched a video, you're like, dang, I didn't understand any of that procedure. I'm going to go look for something online. Provide a link to that. You're now showing that you're making that extra effort. You deserve those extra points. Change the formatting of text to highlight different aspects that are important. Okay? Maybe it says measure 5.32 grams. That's probably important to know that. So draw attention to that. Okay? Using pictures to prove understanding. Those things push it beyond. Kind of make sense? Okay? That is our pre-lab assignment. Before we get to an example, the in-lab is right underneath it, so we'll talk through the in-lab. The in-lab is different than most of your Gen Chem stuff because in Gen Chem, what happened is you just wrote down numbers. That was it. Okay? And now we'll do the fun test that everybody seems to screw up on, but that's because you're nervous. I have a beaker on the counter full of a clear liquid. Use your imagination. What can you tell me? There's a beaker, and it has a clear liquid in it. What can you tell me? You can tell me the volume. Okay. What else could you tell me? You want a hint? Sure. Is it sand? How do you know it's not sand? You're all laughing like I'm an idiot. What can you tell me about that clear liquid? Really, you got no ideas? It's not sand. What do you think it is? That's a gutsy guy. Yeah. We got a beaker with a clear liquid in it, sitting in this room. Like, you really think I'm going to put something super dangerous in here? It's probably water. How do you know it's water? How are you making that educated guess?
I know that if the beaker is full of a clear liquid, and I know water is a clear liquid, but also not in a lab room, so it wouldn't be chemical.
Lovely. If you think back to all of your Gen Chem observations, did you ever make an observation about the color or clarity of any of the materials you used? The vast majority of people do not. Okay? It is insanely rare for people to actually make that observation because it is not a number. and only numbers matter in chemistry. Right? Which is entirely false. Qualitative observations are critical. That's what I want you making observations on. Right? You still need the quantitative. You got to tell me how much the water is. You got to tell me the mass. You got to make those measurements. But you also need to be noting those qualitative observations. I started with a white crystalline solid. Well, why do I need to know that I started with a white crystalline solid? What's that?
Might be something different by the end.
It could have changed into something else by the end of the experiment. Then I would need to know why the end was that other thing. Why do I need to know it's a white crystalline solid? This has to do now with the fundamentals of science. If I told you in my garage, I've been able to wave a wand over the top of a block of lead and it has turned into gold, would you believe me? No. When would you believe me? What's that?
If I saw that.
So magicians do real magic?
Oh, I don't know.
When does it become true? How is it proven?
Experimentation?
Whose experimentation? Somebody else's. I can do all I want, whenever I want in the garage. I can wave my magic wand over my block of lead and say, look, it's gold now. But until somebody else can replicate it, that's not science. It's got to get replicated. Okay? Which is one of the biggest things that you miss in undergraduate education. Right? Do you have time to repeat any of these experiments? No. So you forget all of that replication part. When do you discover that replication becomes important? When you move into industry, right, which is where this whole notebook system kind of came about. I had a colleague through grad school, did her undergrad, got a PhD, started working for Procter & Gamble as a PhD chemist, and they trashed everything she ever wrote. They're like, who taught you to write a notebook? And she was like, clearly nobody did. Because she didn't provide any details. And she was like, that's the number one thing students need to learn. Because when people come out of academia into the research force, you have to be able to repeat an experiment. And if you don't have solid observations, you can't repeat that experiment, in which case it's invalid. It doesn't exist. And it becomes ignored. Only with repeatability do you get that. Repeatability comes from those initial observations. Because if I now go back to that experiment that you performed with that white crystalline solid and I pull out the chemical and it's a purple crystal, something's wrong. Either you screwed up or the chemical I'm holding is wrong. And now we have something to discuss and resolve and figure out. That's where those qualitative observations come into play. Because if all you've provided is the numbers, that simple observation can drastically change the outcome of the result. So your notebook needs to have that information. It needs to have that detail. Kind of makes sense? Okay. Things to help guide it. Time. When you get into lab, note the time that you're making your first observation. Time isn't a critical observation. You aren't going to lose points for not including time. But the point of time is if you get into lab at 2:30 and you know 2:30 we started this. 4:30 rolls around and you're like, I didn't make any single observation for the last 2 hours. You now have something that can point to the fact that you've screwed up and you can remedy that before it gets graded. Okay? That's the point of that time thing. It's a self-check for you. Doing things that are nice, procedure classifications. Okay? When you're doing a particular procedure, what part of the procedure were you attempting to do? Draw attention to that. Sort that out. Okay? What was the actual observation itself? Okay? Color coding matches it to the pre-lab procedure organizations. For the most part, in-lab observations are going to boil down to really one place. Did you note what the substances looked like. I've done these experiments tons of times over. I know what they look like as you do the experiment. Are you noting those physical changes? Yes? Good. No? I'm taking off points. Okay? And it usually shows up as initial OBS, or initial observations, or at the end, maybe crystal color, horrendously spelled, because I'm typing fast. Okay? Make sense? Okay. Last thing, a conclusion. This is, I know it says post, it's not supposed to be post lab. It's really in lab. I just want you to summarize what happened in the lab. This is not a lab report conclusion, drawing big wild things. Oh, this is what happened and this is what this means. No. Your goal was you survived lab. Did you do it? You're writing it clearly, but yay, I survived lab. Okay. You're satisfying the minimum for what I want out of that. Okay. Push on a little bit more. What did you learn from it? Was there any questions that come out of it? Those are now your notes to call attention to what you may need to deal with when it gets to a post-lab. Make sense? You all think you know exactly what you need to do for those?
So if I remember correctly, when I took chem, I think we did our pre-lab, like, it was almost like we're trying to find what the experiment, like what the end result of our experiment is gonna be. Is that kind of like how our pre-lab? That doesn't sound like, it's more like understanding how the lab is.
So yes and no. So that's an interesting question. So that's a complaint that I generally have about general chemistry, is that the lab is to determine Planck's constant. So you go through and do the experiment, and anybody remember what Planck's constant, the value was? I don't really remember it either, but I didn't want to shout out a number and have someone be like, you're an idiot. So, but I think I'm going to say 6.26 times 10 to the negative 34th. Okay? So you go through the experiment, and the answer you get is 4.32. Did you do a good job? No, you horrendously missed the goal. Not times 10 to the negative. You got 4.32, and the other one was times 10 to the negative 34th. Okay? So you did a horrible job. Okay? What does that mean as far as a grade? What's that? Yeah, and I object to that. Why would I object to you failing?
I feel like that's not fair.
Why?
I'm learning.
How many times have you done that experiment before? That was the first time. How many times have you done anything the first time and been successful? Oh, I popped out of the womb and was just walking. Okay, it doesn't happen. It requires repeatability, going all the way back to science. So I have huge problems with a grading system that's set up that way, and I've gotten into fights, quote unquote fights, over that, because I think that's dumb. Okay? What I care about is that you look at that number and be like, dang, I screwed up. This is why I think I screwed up. Okay? That's what I want to see. So I don't care necessarily that you're getting wrong information. I care that you analyze the information you have and draw the conclusions that your data says that you get. And if that means you're drawing conclusions that are wildly incorrect, so be it. Okay? That will be a conversation we can have in class and be like, when you're all like, oh, the recrystallization technique is an awful technique. It didn't purify anything and it was horrendous yield. Be like, well, the yield usually is bad, but it does work to purify. And your technique sucks. Okay? So the results that you're getting out of it don't match what happens at a more experienced level. And we can have that conversation. I want you to learn from what's happening in the lab, not get the answer. Okay? Which is also more challenging. Because when you start a lab on what's Planck's constant, you know what you're supposed to end with. When you start a lab here, what are you supposed to end with? The journey. Okay? That becomes harder to kind of wrap your brain around because you now have to think about that process. Okay? Kind of, sort of? Okay. Worst class I ever had, the instructor asked me to, I was the TA, asked me to line up everybody's samples, and he went through and looked at each vial and was like, that's a white crystal and there's a lot of it. They deserve an A. I literally watched that person pour salt into that vial. It's not the product. And you want to give them an A. I'm like, well, yeah, they have a lot of it. You're such an idiot. But that's how we wanted to grade. That was one of the fights that kind of got into. Seniority issues there were problematic. But yes, so that's our pre-lab and in-lab. That covers a little bit more towards our goals. And within those goals, that's partly what the post-lab is there for. I want you to analyze what you've got, but then I'll also try and say, this is what you should have seen. What things should have happened there. Okay? So, as we continue to scroll through, we get our rubrics set up again in case you wanted to see them. That all the scoring is going to happen in Canvas. So what I do is open up your pre-lab, and I open up Canvas in a separate window. Okay? And I go through and look at your pre-lab and be like, yep, or nope, there's a problem. And so I'll comment in your notebook, but there's no points in the notebook. Okay? So you never see a grade in your notebook. All you see is me complaining or saying good. Okay? Continue to scroll through. Here's our GHS pictograms. Why might we include these? This is a fun one. I think it's hilarious. Most people don't think it's hilarious. But let's say you're working with a gas under pressure in one of our experiments. Okay? Well, your hazard would be gases under pressure as a text, but this has a GHS pictogram. So what you could do is go up to here, and if you click the image, see how it puts a box around it? And then on a Mac, you can hit Command C. Or a normal computer, you can hit like Control C. And then you can move over to the place where you've got it, and then you can hit Command V. And it like puts the picture there also. Pretty neat, right? Yeah. Thank you, technology. Who needs AI? Okay? That's kind of the intent for these, to make that easier to find so you don't have to deal with screen capturing or anything like that. Okay? Hazards, theoretically, you should be aware of these things. These are things that are more relevant for firefighters. That's why they're here. Why you see them on buildings and lab doors, because if a firefighter is busting into the building, they're not going to read all the SDS. What they want to see is the Cliff's Notes of the hazards. Okay? And that's what these are for. Here we get an example. This one's a bit sort of over the top because this is a full-on synthesis. This is, I want to make something. So if we look our introduction, I want to synthesize this goofy long compound name in this type of reaction. Did you read the background information? Probably. You've told me what the compound was you were going to make, and you said Diels-Alder. For those people being like, doesn't the title say Diels-Alder? Stop being observant. Okay? But it looks to me like you read the background information. Okay? I would also be like, oh, dang, you included a picture. So to me, this is perfect points. You provided a quick summary of what's going on within the experiment. It's a little bit weak. You could describe a little bit more, but I'm fine with that. And you gave me a picture. Okay? We just started talking about Lewis structure, right? So you guys are a little bit shaky with it, but maybe you can pick something out. We talked about, at least in class today, that every point was a carbon. What can you tell me about this point right here? That's a carbon, right? With a double bond? Yeah, oh yeah, I even like that. There's a double bond, and then you did this. What was that?
It's like, looks like a double bond though.
That's a carbon with 5 bonds, which means it has 10 electrons around it. Can you do that? No, that's wrong. Whole bunch of what's drawn up there is wrong. It also looks kind of ugly. This looks like someone just drew it by pencil and paper and took a picture with their phone. Yeah, it's lovely. Exactly what I want. I don't need it to be right. Okay? I don't need it to look pretty. I need you to show that you've attempted to think through what's going on. This shows that. You're wrong, so we'll fix it. Okay? But you've attempted that thought process. That's all I want to see in the pre-lab. Does that make sense? I tried to make as many mistakes as humanly possible while still looking like organic chemistry, for the record. Okay. Chemical lists and hazards. If we go through and look at it, we've got our chemical lists. Out here, we've got our hazards. Then I said something about physical properties. We've got molecular weight, density, melting point, boiling point, and our structures. It's organic chemistry. We need structures. These structures look really nice. Dang. Does that mean you have to draw out these structures? Used Google Docs before? Insert, image, web. If you want to be extra lazy, you can take advantage of that Control-C, Control-V thing. I did it again. Okay. And I can just drop the image in with a quick internet search, never leaving the document. Make sense? Okay. So that gets the structures easily. What about the hazards? The hazards you're probably going to have to dig for. Sorry. That's going to require going out to the internet, finding them. How can you find them? Google the name SDS, and that will get you to the safety data sheet, and then you can read through the safety data sheet to decide what words to put in there. Where else could you find that information? Typically, Wikipedia. Wikipedia does a decent job. You could probably find the hazard information there. Okay. Along with, believe it or not, the GHS pictograms, but not in a nice copy-paste format, which is why you might need to go back to the earlier stuff. Kind of make sense? You then get molecular weight, density, melting point, and boiling point. Where can you find all that? Again, Google, Wikipedia, the SDS will have all that information, but that's a lot of individual manual work that you have to go through and find. Okay? There's a little bit of a head shake there, like you didn't like that. That's interesting. Okay? So it would be nice if we had an easier, faster way to do this, right? What does this say? What does PC stand for? I tried to intentionally use the phrasing that would get it. Maybe I didn't. Physical constants. You mean molecular weight? I already forgot. Density, melting point, boiling point? Yes. They are found using this link. Mike and his stupid links. So here's a link. Let's click that link. We got to make a copy again? Yeah, make a copy. Okay, while that's loading, I'm just going to preempt here. I'm going to say, I'm going to select all of those, and I'm going to do that good old Control-C again. I'm going to go back to this document. What the hell is all this? It just says benzene and toluene. It's referencing Wikipedia. It's got chems. I don't know what any of that. Oh, hazards. That sounds familiar. So there's hazards listed out here. Structure, and then it says molar mass, also known as molecular weight, aka MW, followed by density, followed by boiling point. Does that pattern sound familiar? Should sound pretty familiar. Okay, but none of these are relevant. This is all our benzene and toluene. So I'm going to go up to this benzene. Remember I did that Control-C thing? Let's do a Control-V thing. Give it a little bit. Take some time to think. What did it just do? It just pulled up all that information. So now you could go back, select all that content. You could do your Control-C thing again, double back to your document, and do your Control-V. And paste it in there. So you've got all that information really quickly. Make sense? Okay. So this is kind of a happy medium between you doing absolutely nothing to look up all this information, okay, and just have me give it to you, which I think is bad, okay, and you having to struggle through finding everything on the internet. Make sense? Okay. For those people aren't the structures here, couldn't you control copy those too? Google doesn't like copying images, particularly multiple images. So if you tried it, it doesn't paste appropriately. You can do it individually, I think, but that's about it. So sometimes this document will pull up the hazards, like it did here for benzene. Most of the time it won't, and that's because the hazards are stashed in weird spaces, and how this document works is trying to comb the internet for that information, and if that information is not stored in a central, easily identifiable place, this programming can't find it, and so it doesn't pull it up. Kind of makes sense? Within this document, the only column you should be editing is this chemical name column. Okay, you have the ability to search for 17 chemicals. Okay, if we have more than 17 chemicals, I don't think we do, but if we have a lab that does more than 17 chemicals, just copy and paste multiple times, okay, within the same cells. Does that make sense? Do not add more rows. Do not mess with all this text down here. There's weird formatting, programming, mumbo jumbo that I've tried to reverse engineer, and you don't want to mess with it. And I just broke the computer. Okay? Kind of makes sense? But that'll get you your physical constants relatively easily, hopefully. Okay? Why do I want access to that information? Why do I need a molecular weight? Any ideas? Nothing? I do an experiment. Actually, let's do it real simple. We decide to be gold miners, and we're going to dig up some gold, and we're going to test it to see who should be actually mining the area where they got their dirt. You guys go out and mine, and you find, I don't know, a gram of gold in your search. I go out and mine, and I found 10,000 grams. Who's got the better mine? 10,000? I mined across the entire nation. You mined in your backyard. Who has the better mine? Okay. Your backyard's probably a hell of a lot better than where I've mined. Okay? So absolute values of, oh, I made 5 grams of product is meaningless. If you started with 100 grams of materials, 5 grams of products is pretty weak. Okay? So what we want to do is a way to normalize it. How do we normalize that in general chemistry? Everybody's favorite. The little S word used frequently. You use stoichiometry to calculate a percent yield, limiting reactant, all that fun stuff. Yeah. We don't do it very often. In fact, this semester I think we do it twice. Okay? But that's why you need a molecular weight. You're trying to convert one substance to another substance. Like, that's the whole point of chemistry, okay, for the record. So that's why we need molecular weights. If we've already looked it up, we don't have to worry about looking it up a second time. It's already there at our fingertips and immediately in our document that we're using. So it's useful to have. Why do we need the density? Okay, as we'll find for the solubility, you're going to mix 2 liquids. Which layer goes on top? The less dense one. If you have your densities, you know that information without having to experimentally do anything. So that can be powerful. Why do we need melting points and boiling points? I got that clear liquid up here, and it boils at 100 degrees Celsius. What can you tell me?
Water.
How do you know it's water?
Because that's the boiling.
Boiling point is a very consistent thing for an individual substance, okay? Which means if I know the boiling point, I can potentially identify the substance. So if I know that stuff, I also have access to it. I don't always need, for instance, the density is not useful when I'm looking at a solid. Because what am I going to do with the solid? Dissolve it into a solution. The density now is irrelevant because I'm looking at the density of the solution, not of the individual solid. Okay? But do you really want to spend the time to be like, oh, this one's a solid, so I don't need the density. This one's a liquid, so I need the density. Or do you just want to go, I'm just going to find it all? Okay? In this case, finding it all is a whole heck of a lot easier than having to do the little nuancing stuff. Make sense? Cool. Procedure text. Here's our procedure text. What do we need for the procedure summary? Okay, since this is a full synthesis, this has all the bits and pieces on it. We look at the procedure summary, we've got our synthesis pulled out, we've got our separation, purification, and identification. And if we take a look at the actual text, all that's really happened is a copy-paste of the text up here, but into different paragraphs, separating those sections apart. Okay? For you all, it'll be a little bit different. You're going to read the procedure, and then you're just going to write what you remember about the procedure. That's about it. Okay? Evidence that you've read the procedure. Make sense? In-lab observations. This table is not a requirement, but most students have found that they get really irritated at seeing the same "you didn't observe the crystals" comments, that they built tables where they listed all the compounds and the color and amount used during the experiment, so that they know when they get into lab and they see this, that they have to fill in the table. And it ensures that they make those observations. Okay? Entirely optional, but it's a nice organizational system that lots of students have picked up. Make sense? I'm gonna back that out. The rest of it is now just making observations about what happened in lab. Note the times. You can read through the observations. They aren't super detailed. Okay? They aren't necessarily complete sentences. What you're trying to do is just make general observations about what's happening during the experiment. Okay? You can make fun of your partner, you can make fun of me, doesn't matter, just do it. Okay? The last thing that's super powerful within our in-labs, okay, a picture is worth 1,000 words. If you were doing just a standard notebook, how do you get a picture of your experiment into the notebook? You draw it. Are you an artist? No, so your drawing sucks. Okay? How do we get a picture of our experiment into the lab? You take a picture and insert the image. Like, that's the beauty of having a digital document. Okay? So while you're doing the experiment, take a picture of each of your individual reactions. You need a description saying what that picture is about. Okay? Just putting a bunch of random pictures isn't useful, but that provides that second layer of information that allows us to ensure that we're doing it correctly. Make sense? I need edit access because what I can do is insert images of spectra. We'll learn about spectroscopy later in the semester. Don't stress a whole lot about it now, but you will eventually be able to interpret this to get some information out of it. Okay? As the experiment goes, I'll dump it in there instead of having you because I never wrote the protocol. Okay? Conclusions, again, while a giant mess, this is not a lab report conclusion. This is a finished lab conclusion. Make sense? We scroll through. What we now start into is our solubility. The solubility one has a slightly modified introduction. I want you to complete the table. I take these two things and mix them. What does it look like? Draw a picture for me and use some words describing what that picture shows. What do I mean by picture? Here's a perfect example. These two things I attempted to mix. Okay, this is what I think it looks like. I got this green squiggly line because those are green squiggly lines. I got this black squiggly line because there's a black squiggly line. I think the layer's mixed. That's why it's black, green, black, green, black, green. This says did mix. Did the picture make that obvious to you? Some people are like, yeah. Most people are like, I have no clue what you're trying to draw. Right? That's okay. That's why you use words. So you use both. So for this introduction, all you're doing is completing out the table. Okay? For the chemical lists and hazards, I provided the list of chemicals for you for the very first one. Look at me being so nice. Okay? You have to fill out the rest of the table. Procedure text. This is a long procedure. So you would read through the entire procedure, and then you'd go to procedure summary and write down what you remembered. Theoretically, as you read it, you might notice that we have a part 1, a part 2, a part 3. And so what you could probably do is say, well, the goal of part 1 is to mix a bunch of liquids. The goal of part 2 was to mix a bunch of liquids. But these liquids are just water and this all. Do you know what an all is? No? I don't care. You don't need to know. You just need to know that you're mixing them. Okay? You're proving that you've read it. That's it. Make sense? Okay. In-lab observations, tables. People seem to like tables for this particular experiment, so I've generated a bunch of tables for you. You do not have to use the tables, but they're there in case you want to use them. Okay. Wrap it up with our conclusions. Part 4, this is part of the scaffolding. Part 4 we may or may not do, actually, but there's no organizational system for it. So if you want to build the part 4 tables, you can. Then you'd finish your conclusions. What happens when we move to the next experiment? Introduction, it's blank because I want you to do a normal introduction. Chemical lists and hazards. You need to find the melting points for these substances, okay? And then you just need to find the other chemicals and their hazards for the other substances. Okay? How do you find out what substances? You read the procedure text. Once you've read the procedure, you can do the procedure summary. Note the in-lab observations. There's nothing there. This is now all on you. Models activity. We sit in here and you play with models, effectively Legos, for 3 hours. Yay. It's fun-ish. Okay. It's a very personal one. It gets a little bit strange because there will be lots of awkward eye contact, because when we're dealing with models, it only works when both of us see the same thing. Okay. I'm at least comfortable enough to see it inverted. So what I'll do is end up showing things to you where I know you're in line of sight and I know what it's supposed to look like from that side because I'm looking at it from the other. Okay? So we'll get a lot of weird kind of positions like that. That one can get friendlier than I would like it to be. Thin layer chromatography, and now you're seeing the pattern kind of build all the way out. Make sense? Okay. Phew. You guys want a break? 20 minutes, I'd say, and we're done.
20 more minutes, or take a 20-minute break?
No, 20 more minutes and we're done.
Let's just power through it.
Okay. The lab report analysis is done similarly. So it's another one that you would do a copy document. Note this one just says last first, not last one, last two. Why?
It's not just yours.
It's just you. Okay? It still needs to get shared. You need to share it with me. Okay? The whole point of the Google Doc is you share it once, you don't have to worry about it again. And we'll talk about the beauty of that in a second. Okay? Just because someone decided to do it last semester, I want to be extra clear on this. Do not revoke my share access, at least during the semester. After the semester, do whatever you want. Okay? But during the semester, don't remove my access. Because if you remove my access, I can't grade it, which means I can't give you points, which means you get a 0. There was a kid last semester that kept doing that the entire freaking semester for every bloomin' lab. And you know what he forgot to do with the very last experiment? Give me my access back. So for 10% of his grade, he got a 0 because he didn't give me access to the flippin' report. Share it with me and forget I'm there. Just do that, please. Okay? But this document has all of the post labs for all of our experiments. Okay? I don't want this being shared with anybody else. But you can still talk with other people. You can sit in the tutoring center with the assignment open. Let's go to solubility. Okay? We go to the solubility assignment. Okay? We got a question, you need to explain the results. So explain your results. Okay? Part of that explanation can be talking with other people. I'm okay with that. In fact, I encourage that. The issue becomes when you have the same answer. Don't have the same answer. Okay? The easiest way to fix that, talk with somebody about question 1. You guys decide, oh yeah, we totally understand this question. Move on to question number 2. Talk about question 2. Once you're done talking about question 2, go back independently, write question 1. Write your answers to question 1. Put at least a 60-second time span between you talking with someone about the answer and when you write the answer. That time span should be enough to break the language cognition down that you aren't at risk of copying each other and running into plagiarism issues. Make sense? Okay. Yes, sir.
I have a question going back to the notebook.
Yeah.
So do we each make our own individual one? We just
There's
share it.
one.
We have one between.
Yep.
Okay.
And what's the extra beauty on that? You've worked with lab partners before, right? For all your other classes? Okay? What happens if your partner took the notes but you didn't? You don't have the notes. What happens when you try and write the lab report? You're making stuff up if you're lucky and don't get caught. Right? I've had some instructors be like, that was your responsibility to get the notes. If you didn't get them, that's a 0. Okay? That issue disappears. It's a shared document. All of your notes go into this. Okay? And they should be going in as you do the experiment. Okay? This does introduce some issues. Who does the pre-lab? Yeah, both of you. You both get credit for it. There's one grade for both of you. It doesn't divide up. How do you want to divide it up? I don't care. I really don't. Okay? One of the tutors, probably one of the best students I've had in a long time, active tutor, usually at Williams though, revealed at the end of the semester that he did not do a single pre-lab. You're such a prick. Why are you telling me this? But his partner did it all. His partner did all the pre-labs, and his partner actually did all of the in-labs. He would just kind of do the experiment. He'd read everything, and he'd be prepared. He just never did the work, and his partner just did the work. And his partner was happy with that. I don't think you should be happy with that, but that's not my choice. Okay? You should try and find a way to evenly divide up the work, however you want to do that. Kind of, sort of. Right? I will say that if one person is like, I am doing way too much work and this is awful, number one, you should tell your partner. Address it with them first, ideally. Okay? But there's this thing called the version history that lists all the names of people that have edited. I can open this up at any point and I can be like, there's only 2 names in this version history. Mine and one other person. The other partner has contributed nothing to this document. If they've contributed nothing, they deserve nothing. Okay? So there is a mild checks and balances behind this. I can revoke points very easily if I don't see that you're both contributing to the document. Does that sort of answer your question?
Yeah.
I threaten that I will always check the revision history. I don't check it that often. I check it probably 2 or 3 times during the semester. Okay. If any one group complains through any of the sections, I check them all. Okay. So there's random kind of spot checks, and then there's also someone's got a problem. We need to fix that problem, and I'm not going to target a group. I'm going to target everybody. Everybody gets hit with the same hammer. Okay? So you would go through and just complete within this. You have to complete it by the due date, which is the Friday 1 week after. So this particular assignment is due February 6th, I think we said. Okay? What if you don't have it done February 6th? What's that? How would you lose points? If you think about a normal lab report, you start losing points because it's supposed to be turned in, right? You turn it in, and if you don't turn it in, you lose points. You turned it in as soon as you created it by sharing it with me. There is no manual turn-in, which means when do you lose points? When I start grading it. That's when it's late. Which means Friday night, you're still working on it. Do you think I'm going to grade it Friday night? For the record, I have 2 kids and a wife. No. Okay. So you probably can work all through Friday night. Do you think I'm going to grade it Saturday? I will say Saturday, I usually try and carve out 2 or 3 hours to get some grading done. Okay. We'll see. This semester's I've got less classes, so I'm hoping to not work at all on the weekends. Which means, am I going to grade on Saturday? Am I going to grade on Sunday? When am I going to grade? Probably Monday morning. Okay? Which means you are desperate for time. You had another assignment build up. Okay. You could ask for an extension. That's fine too if you want to play it super safe. Be like, can I get an extension? Life just hit me. or you just keep rolling with it and make sure you go back and finish it. Okay? And this is, I think, the big benefit of the Google Doc. Okay? When you turned in an assignment before, how did you know that you did something wrong? When it got turned back into you. Okay? So if we look at a pre-lab or an in-lab, okay, you find out how to fix your pre-lab by the time they gave it back. How good are your instructors at turning things back? Most people say they sucked, right? Yeah. So by the time you get feedback on that first report on what to fix, you've already submitted 3 others. All those other 3 are now going to suck. Okay? This way, you get that feedback, or if you don't get that feedback, you're like, dude, you're behind in grading. I just got to wait till that grade comes through, and now I can look at that feedback to make my adjustments on the next section. Make sense? I think this is nice, both for students and for faculty. We good? Okay. I need to talk a little faster. Last couple things we'll address. Technique summary directions. Okay? There's a Tuesday lab, Wednesday lab, Thursday lab. You're a Thursday lab, so you will open up this document. This document is an open access document. Anybody in the world can open this as long as they have the link, which means everything you put into it is perfectly anonymous unless you designate yourself into it. Okay? I would officially say you need to be anonymous within the document. The point of this is that you are trying to generate a Cliff's Notes for all of the techniques you learned this semester. For those students that have to move into OChem 2, all of these techniques show up again. Do you really want to repeat each of those experiments to get that information so that you can do the next experiment? No, it might be nice if you had some Cliff Notes. Ta-da, make them. Okay? Here's the caveat. It's a group document. Your section, everybody in this room, other than me, gets to make it. Okay? So as we complete a technique, solubility, they're listed here, I would recommend you add some information in. Ooh, this was super important. Man, that thing almost exploded. Mike almost yelled at me. We got to make sure that we don't do that ever again. Let's make sure people don't miss that. Okay? So start building it out. Okay? As a group document, you all must contribute. How do you get credit for contributing? Okay? I don't know if it's in the directions or if it's in the reminder, okay? But you will be able to have a technique assignment where you submit. What I want you to do is when you go into the Google Doc and make an edit, screenshot it. Put the screenshot into the Canvas. That's your paper trail that you did credit, that you worked on it. Does that make sense? Okay. That doesn't mean what you did was good, and somebody else can be like, that was crap, and delete it. That's okay. That's why I want it to be anonymous. Okay? And it may not be, I don't like it. It could just be, I don't like the way that was formatted, so I'm going to change it. That's okay. Okay? But what I want you to do is each contribute into this as the semester goes for each of those individual techniques. The intent 3x5 note card. That's what we're looking at for each of the experiments. Pictures are great. Words are great. Come up with a way to make sure that that information, the key essences of that individual technique are transferred. Make sense? Ish? Okay. How many people like group work? Liar. Nobody likes group work. Okay? Or maybe I'm just a pessimist. Okay? It's always hard to work in groups because you got to get everybody to communicate, everybody do the same thing. Everything that you're going to do in the outside world is group work. The only way you don't do group work is you're self-employed. Okay? And even then, you usually have to do group work because you still have to work with somebody else somewhere along the way. Okay? So we need to have that experience of working with people. Okay? It sucks. Fully appreciate that. Okay? So we need some kind of grading systems set up within this. Number one, there's an example there, but let's look at our kind of contribution. Okay, it's going to get a single grade for the entire assignment. It's 50 points. Okay, so whatever I assign to it, every single one of you has the potential to get those points. Okay? So if it's perfect and glorious, 50 points, everybody gets 50 points. With one caveat, there's a multiplier. Okay? That multiplier has to do with your contribution. Did you not contribute at all? You don't deserve 50 points. Your multiplier is times 0. So I will take 50 times 0 and give you 0 points. Okay? That's why you need the paper trail. Post into Canvas what you did. Okay? You just contributed a little bit. I didn't think it was really worthwhile. I'll give you half the points. Okay? Or you all contributed roughly equally. Fantastic. Multiplier is 1. No modification. Everybody gets the same points. Make sense? The last one that's a little bit tricky. Okay? Because every time I've seen group work, and I'm guilty of it too, be like, I don't trust my partners. I'm going to do the whole thing on my own. Okay? That's crap. That prevents other people from learning. There's also a multiplier for doing the whole project on your own. It's 0.75. Okay? So if you just want to go and, I'm just going to finish everything, the most you're going to get is 75% of the points. Okay? It is a group project. You get a group grade. So if you're going through and working on it and being like, dang, this isn't done yet, I'm waiting for those other people to contribute, okay? But I don't want my grade to suffer, okay? That's also something I want to mitigate. So 2 weeks before the due date, I will say it's open. If you haven't contributed by this point, you are at a very high risk of getting a 0, okay? But at that 2 week point, anybody now can go in and be like, I did not like that, I'm fixing all of that. That's fine, okay? That prevents, at that 2 week line, that negates this excessive contribution. Okay, that one now goes off the table. Make sense? Okay. Sounds kind of spooky. I think it's kind of scary. In general, it's not a big deal. I disagree with y'all, whatever you put out, but I wasn't in the group, so it didn't really matter. Okay? As long as the information is there and I feel you've satisfied the assignment, I'm okay with it. That's where we get an example for thin layer chromatography. In this case, thin layer chromatography is being described as a purification system. Describes roughly some information about it. That's roughly what I would expect. This one's missing some stuff because there's no pictures. Put in some pictures. Make it look nice. Okay? Kind of, sorta? Okay. Almost the last couple things, I promise. Just one more hour. It was a joke. We talked about the activities. Okay, week 4 and week 6 are these activities. The model activity is fun in class. The spectroscopy assignment, everybody's going to hate. I think it's awesome and great fun, but it takes a lot of kind of back-end work to kind of build up to. It should be a little bit easier for you all this semester because typically it's all online. Now we'll still come to class and we'll talk through it, but it's still painful. To give you an idea, oh, look, it loaded faster this time. Okay, what you've got are 10 pages that look roughly like this. If this was one of the 10 pages that you decided to do, your answer is telling me all the work that leads you to say what the structure of this compound is. So you just have to interpret that and say, yeah, this is what the compound is. I just want to see all the work to get there. Okay? So that's the spectroscopy assignment. Like I said, I think it's fun. Any puzzle fans? Anybody like puzzles? Nobody likes puzzles. If you liked puzzles, it's very much a puzzle. Okay? I would argue what this is you're putting together puzzle pieces so that you can put together the puzzle. Each of these is a piece that gets you a little bit of information that you can now connect with the other pieces to come to a final conclusion. Just kind of neat. Okay? And if you're looking at trying to figure out what the answer is already, you are crazy. But yeah, go ahead.
I have no idea. I was just saying, are these 4 images like go with the same compound?
Yep.
Show how they do?
Yep. So what you would do, so for example for this particular one, okay, we can do some quick analysis. For this one right here, based on what we see here, this signal means we have CH where the carbon is sp3 hybridized. That is all we get out of that spectrum. That's it. So 2 seconds, I have some information. Okay, do you know what sp3 hybridized is? No, it's okay. Yeah.
How do you know that it's SP3?
Because it has to do with the peak shape and where it is located. So if we look at it, there's the shape, obvious is not the right word, but what we're looking at is that this shape right there, what that looks like is different than what that looks like, is different than what that looks like.
And with the hybridizations from other ones be different?
Maybe. Because it's not just what it looks like, it's also where on this axis it shows up. Okay? So there's a hybridization effect, and then there's also what are the atoms. Okay? Because that CH is not OH. Because OH shows up over here as a broad signal.
The little point?
This OH would be a broad signal over here. There's nothing there, so I know I don't have an OH.
Okay.
So what it comes from is trying to represent what you're seeing there. Some of it is quantification, but it's quantification used based off of location, not used off of I'm going to calculate some numerical value that comes out of it. It's just like that signal, the number's really hard to see there, but that says 3,000. That red thing that I drew in, those peaks show up under 3,000, so a value that's smaller than 3,000, and it has this sharp kind of pointy shape. Those two pieces of information together tell me I have a carbon bonded to a hydrogen, and the carbon is sp3 hybridized. If those peaks showed up here, here, I would now say that that's something different because it's not showing up less than 3,000, it's showing up greater than 3,000. Now it is a carbon to hydrogen, but it's sp2 hybridized, or it's sp hybridized. So that structural information is encoded. You'll note that there's a crap ton of peaks over here that I didn't say anything about. Why? Because there's a crap ton of peaks over there. It's too hard for me to interpret. That's known as the fingerprint region. Did any of you check my fingerprints to verify I was who I said I was? I mean, fingerprints are unique to a person. Why didn't you do that? Well, it's flipping hard to do. We make a bunch of assumptions about the larger images first, and if we really need to, then we'll push the fingerprint. Like if I'm going to go to jail, they'll probably fingerprint me to ensure that I'm the proper person that's put in jail. Hopefully. Okay? So depending on what you're trying to get out, you'll analyze those pieces differently. Therefore, or technically 3 different forms of analysis. So if you think back to Gen Chem, you probably did something UV vis, ultraviolet visible spectrum, or colorimeters, things like that. Does that sound vaguely familiar? Beer's law. Okay. What you're using there is the ultraviolet visible spectrum of the electromagnetic spectrum. That was silly. Okay. And that causes particular things to happen within a molecule. That's electron excitations. Okay. The first one, the one that we've now colored on, is using infrared light. Infrared light is lower in energy. Can't actually cause the electrons to jump energy levels. What does it cause the molecule to do? Vibrate. But it vibrates in a very particular fashion depending on what atoms are connected to it. Okay? The upper right-hand corner is a little bit different because it's destructive. That upper right-hand corner, the analogy I use is if you've seen a CSI show, they do all the forensic analysis and oh my God, there was this car bomb and it blew up and we figured out who made it because we were able to dissect all the pieces. That's that. What we do is we strap a car bomb to our molecule and we explode it and we look at all the pieces. Okay? And by reverse engineering how it could explode, we can figure out a potential structure. Okay? We don't use it that deep. The bottom two are now using radio frequencies. Radio frequencies cause nuclei to change and vibrate. Okay, so we can test and monitor that to determine its chemical positioning, which is pretty wicked. Okay? But it requires lots of kind of secondary interpretation behind all of that, and ultimately all you need to do is, where's the line? Why is the line there? That means this. You don't need to get into the physics behind any of those pieces. Okay. But it's neat. Yeah, Jess?
Is this something we're gonna learn?
Yep.
Okay,
Yep, it's unit 2. It's unit 2. Okay. So the way I've structured it, I guess would have been nice to tell everybody in lecture. Unit 1 is how do we represent organic chemistry? So it's all representational. So we look at Lewis structure, we look at Vesper, we look at models. Okay. How do we think about and draw these things that we can't see? Okay. Unit 2 is how do we know that those things actually exist? That's spectroscopy. Okay. Unit 3 and the rest of OChem are, now that we know these things exist, how can we change them? How do I run a chemical reaction to make something else happen? Okay. Which I love that organization, for the record, but spectroscopy is taking so little like national attention, I guess, or curricular attention across the board, that it should really be shifted to be at the very end of the semester, because at the very end of the semester we talk about stuff that's very, very, very important, but it's the end of the semester. You're brain dead. Okay, which means all of that content I talk about, you have no clue. It's in one ear, out the other. When we roll around a second semester, I have to reteach it all over again because you don't remember any of it. Okay? I would rather that happen to spectroscopy because it doesn't show up as much. But that structural reorganization within the class decided I could not safely pull off this semester. I think there would be too many changes happening and it would screw something up. So that's for the future, I think. Okay? For the record, I'm a little nervous and scared and excited that you all seem so interested in spectroscopy. That's kind of cool. Okay. After that, there are these things, WAC. You'll see WAC and you'll see lit reviews. Okay. You do a ridiculous amount of writing for any chemistry lab. Okay. And typically all you get credit for is chemistry. That's it. Okay. A couple people within this institution and starting to be more nationally are recognizing that writing happens outside of writing classes, and students should get credit for that writing. That's what writing across the curriculum, or WAC, or writing certified, means. This course has been certified beyond your control that you do a bunch of writing. Okay? And as part of that, they want some of these kind of checks put into the course. Okay? Do not stress about them. They're mostly personal narratives about how you feel about writing and how you feel your writing in science is changing due to the course. That's it. Okay? If you're writing more than 2 pages, you did too much. And when I say 2 pages, I mean double spaced. Font size 12. 2 pages, too much. Okay? Ideally, you're sitting in that page line. Okay? But what it's trying to get you to do is to kind of think a little bit more about what you're writing and why you are writing. As a benefit, if through your career at Chandler Gilbert you've taken enough classes that are writing certified, you get a special little stamp on your degree or diploma saying that you are now writing certified. Okay? Most science students don't get that certificate because there's not enough science classes actually contributing to it. On top of which it's a credit limit. You only get 1 credit for this. You do more writing in this class than probably the writing done in English 101 and English 102 combined, which is ludicrous, both at the level that you're doing that much writing and at the level that English 101 and 102 don't do that much writing. Okay? So that's why they're there. If you've got questions about them later as they pop up, you can ask. But again, I think those are mostly self-explanatory and pretty straightforward for me to grade. I just kind of scan through it and be like, it looks like you attempted this roughly within the intent of the assignment. Thank you. Here's your points. Okay. We're nearing up right at the end. So what I am going to go ahead and do is stop.